I reckon.
My name is Greko.
I'm Fabian Rothschild. We're from Miami. I'm here to talk to you about botnet resistant coding. Can everybody hear me okay in the back? Everybody hear me? A little bit.
We're actually bilingual Americans. I know there's trilingual, bilingual, and then there's Americans. But we are actually bilingual. I'd like to see that this is not intended to teach people how to use malicious tools. Serves as an awareness of their existence. Just to get that straight. I know there's a big law around here about that. And no criminals or web servers were harmed in this presentation.
Also, we tend to talk a little bit fast, so if you can't understand or you want us to slow down, just let us know. If you have any questions, just raise your hand. We'll get to you. Anytime.
Okay. We're basically going to go over a brief explanation about botnets, in particular the Zeus trojan, one of my favorite. We're going to go about the psychology behind the typical botmaster, HTML basics, and then methods of botnet resistant coding. So, we're going to talk about infection rates. 400% of all computers are infected with malware, mostly from stuff.
Okay, so how does Zeus work? Zeus is, everybody knows what Zeus is. It's a trojan that'll sit in your computer, it hooks the browser, and begins intercepting all the encrypted data that you're sending in field submit post requests. Form submit post requests. So when you log into your bank, before the SSL function encrypts the data, it hooks that function, takes that data, sends it off to the command and control, and control continues in the program. By default, it uses Internet Explorer only, but plugins exist for Firefox and things like that with their plugins. The infected machines communicate with the command and control server over HTTP post requests. They're not HTTPS, but they are encrypted with an RC4 symmetric key, which is the same for the entire body. The command and control server is a very user-friendly PHP application. It has like an installer, and it has instructions. There's a help file. It's very nice.
In English and Russian?
Yeah, it's in English and Russian.
Both languages.
They know their target demographic. The way it propagates normally is through phishing campaigns. A lot of bank phishing and just pretty much anything, e-cards, stuff like that. Peer-to-peer, it'll also, there's a lot of people who go on BitTorrent and they'll download some popular application, backdoor the installer, the keygen or something like that, put it out on the internet, and everybody just downloads it. And hey, they also use exploit packs. What these are usually is they're embedded iframes in third-party sites that are hacked, usually WordPress, things like that. And what those do is they'll run exploits against your browser. Very popular exploits, PDF exploits, Flash exploits. Usually they have 7 or 8, and it'll automatically install a bot for them. Social engineering, we already covered the phishing stuff. There's a lot of other methods, but like if you're testing your own bot, where you're going to install it, your own computer. So sometimes that's the way of propagating. The payload injects into the older versions. The default install will inject a thread into services.exe, so it won't show up as a separate process in the process list. It'll also have system level privileges. It'll hook Explorer functions so that you can't see the directories where it hides its configs and things like that. So thanks for that. It has a very low antivirus protection because there's a lot of diversity with regard to until it's running, turning it off.
Okay. Basically, Zeuss works by they get a builder. They purchase a builder usually from an online form, or they hire somebody to set it up for them. That's really popular. Then they get an exploit kit along with this, usually Fragus, Unique, Phoenix, Eleanor is a really big popular. They even came out with an open source one. Really good. They generate the payload for the executable, which they then come up with a campaign for spreading that thing, which was the message we talked, usually using the exploit kit. From there, the affected machine becomes infected, starts post-logging the Explorer functions, and then sends it encrypted post to the CNC server, which then it logs it into either a database or a giant text file for parsing, harvesting credentials, and then you make them up. This is a Zeuss command. Zeuss control panel, as we can see, the main function that we were concerned about is the post thing, but you want to explain what you
here's a screenshot of the panel. Gives you a lot of interesting information, like total reports in the database. That's every single time a bot phones home, it'll make a report in the database. So we have 245,000 there. Total bots 882. Total active bots in the last 24 hours, which is really the only thing they care about, 40%. So they have a pretty good turnover rate. Gives you the version of the bots, because you can actually use the panel with different versions of Zeuss. Here we can also see the installs. This campaign looks like it was targeting Great Britain and Ireland. The most installs are in Great Britain, and then it shows you how many bots are actually online right now, 147, and what country they're from.
Now, we know this is an older panel. We did the actual initial stuff, so I know the 2.0 is now, and 2.1 is the king one. Yes?
Do you know a way how to Google dork? Command and control?
No, you don't have to Google dork.
You don't have to do it. Actually, we will discuss methods of doing research on botnets later.
Yeah, there's a wonderful website called Zeuss Tracker.
Yes.
The reason it exists is so you can block the command and control servers on your firewall. They have like nice lists of IPs.
Yes.
He's a Swiss guy, I think, right?
No, check it.
Yes. It's a use. It's host.ch.
It's a use.ch.
Yeah. By the way, nobody's here from there.
Is anybody here from Zeuss Tracker?
No.
You know him?
The last research done too, there was the guy who was responsible for this website was here in the
Okay, yeah, we've been having trouble like contacting.
Yeah, we'd love to talk to him, actually. And thank you. Okay. This is a sample report file.
As you can see here, this is actually one of the reports from the Zeuss phoning home. It gives you all this data every single time. I guess if you're suspicious of somebody messing around with your botnet, you could take a look at it. I doubt that anyone does. But it gives you the bot ID, the botnet there. That's actually the campaign name. That's just the default name. It gives you all the system information. It will also give you the IP, the process that it actually is injected into. Here you can see it's Internet Explorer, and then it will give you the source of the post request that this is a log for.
It's about $100.
Yeah, so as you can see, that's a Canadian PayPal account. So next down here, this is the actual report that they see. These are all of the post parameters that you have there. Up there you can see login email, login password, country code, first name, last name, credit card number, credit card type, expiration date, CVV, pretty much everything you need to start doing fraudulent charges on their card. Also give you their email address and the browser and pretty much everything else that PayPal asks you for when you type in your information into the form. So botmasters, how do they work?
Yeah, generally botmasters tend to have low technical skill overall. we know there's good guys, we know there's really smart guys. I've seen what they can do, which is pretty nasty. But they generally have low technical skills. Most botmasters actually buy the software on the forums, and they usually buy it with an exploit kit, and a lot of them pay somebody to set it up. Because cybercrime is an actual full economy. So, I mean, there are people that specialize in just setting up botnets for people and stuff. A lot of them use common passwords for a lot of their botnets, or they use the same password for their email and their botnet, which makes things fun. They're very impatient because, you know, as we know, time is money. And many times a seller will set up many different botnets for different people and use the same password for all the same botnets. So this is going over the actual cybercrime economy from a botmaster. A botmaster usually works with a guarantor. Now, as we know, this is a business, so, you know, quality of product and basically a weird form of ethics is definitely needed to guarantee that you're selling something. So, if you do rip somebody off, you often get flagged as a ripper, and you're usually banned from most of the economy sites that are out there. A guarantor takes about.
Yeah, usually the guarantor will buy the bot data in bulk. Usually what they'll do is they'll sell it by the gigabyte. So they'll have like some set price per gigabyte because they don't want to have to look through it, get all the credit card numbers, they just don't care. So, you know, they have a botnet with 10,000 people, you know, you can get a couple gigs in literally, you know, a few hours. So they sell it by the gigabyte, the guarantor buys it, and they will pretty much mine the data for, you know, the interesting tidbits. They'll get the gold out of the order. And, you know, credit card numbers go to carders, they'll sell, you know, admin accounts to extorters and things like that. Facebook logins usually end up on porn sites, and emails and email logins to spammers so that they can, you know, proxy things through. Here's an example of a forum post. Somebody selling credit card numbers, bank logins, probably more than likely from a botnet. Just so much. He's got track 1 and track 2, which means he's probably also doing skimming stuff or buying data from spammers.
Or he's hacking into.
Or he's hacking into POS machines and things like that. Right. This is what happens to the Facebook logins and the emails. You know,
Talked about privacy earlier.
Yeah, just because, you know, Facebook has the don't show this to everybody button doesn't mean that nobody's ever going to see it.
And log in.
Yeah.
And download.
You know, these things also come from, you know, hacked MMS servers and things like that. But for the most part, it looks like these
Mail accounts too. They harvest pictures out of any mail account they can log in.
And this is an international thing. This is a Chinese site we found. Those all look like
Pretty much.
pictures.
They advertised that they had hacked email accounts, which they harvested pictures of for your enjoyment.
Back to the log here. Again, the bot information up there. The botnet, that's another default name for a different version of the panel. Here we can actually see somebody logging into a Google account. And then here, if we, where is the credentials?
Credentials were there. No, this is good.
Well, it should be posted somewhere. Well, I guess we cut it off accidentally. But here in the post request, you can see the username and password. But, yeah, here's the email, the password. And then up there, there's actually the keylog output.
So not only does it capture the post data, it also does keylog. So if you mess around with the post, it still has the keylogs. We'll discuss that later. So,
and here's another example of the Twitter login with the keylog, and then down here you can see the parameters.
okay. Does everybody know HTML basics? Pretty much. Everybody knows what a GET request is. You know. I come from America, and we gotta.
Yeah, wait. Sometimes we
Yeah,
we have to explain this.
Yeah. All right. So, but we're gonna a GET parameter is going to be very important for resistant coding because Zeus and other trojans log post requests, but they're not logging GET requests. which is a really good technique we're going to talk about later. So we did some stuff on server load, and we're going to represent it with these symbols.
Yeah, these are the different levels of server load for the different methods of for the different methods that we're going to talk about.
Real precise, colors. Okay, we're going to be talking about three methods. Basic methods is changing form variables and adding new form fields. Medium, data mangling functions. And then hard, we do AJAX post methods without form submit. And to be extra evil, we're going to do optional RC encryption. Okay, basically we're going to focus on disruption because since they're trying to make money, we're going to hit them in the pocketbook. And that's exactly what we want to do because when you fuck with people's money, they get mad. You can't even do all sorts of stuff, but when you fuck with their money, this is country. So, easy, confusing credential harvesting by avoiding easily searchable fields. Medium, loading logs, making them less valuable to the target, the bottom line. Now, the first two methods, the keylogger is still active, but the actual hard method, it is keylogger safe, but we know some trojans, like Spy, just log all the posts, and we'll deal with evil methods of fucking with that later. So, let's go for the second one. Basic, we're going to talk about obfuscation of variable names and extraneous hidden post parameters. Now, a lot of people name variable names, programmers do, that names that they can easily recognize and deal with. Next. Right here in the log, you don't need to name it CC number. I mean, a lot of these botmasters, they get so much data that they run search functions to look for it. And one of the search functions they do is CC number. Okay? This is in forum tutorials to say, look for CC number and you'll find a bunch. Okay? So you don't need to name it CC number. You can name it XLPQTC75, just create a long string. It doesn't need to, and there's so many sites. This is pretty powerful. So, I mean, like, what the hell? So, in hidden forms, okay, you can put hidden things because they don't know if it's hidden or not. They just see the actual posted data. So you can put fake stuff like access level, value administrator, they'll jump all over that, or you can make it nice. You can bloat the logs with a whole bunch of gibberish. This is a lot of fun to do. Which makes, because the logs are, less useful data, that lowers the price and lowers the credibility of the guy, which hits him in the pocketbook. And as you can see from the user, they just see a regular page, but the post has all this crap in it. And here we go. Let's take a look at this. So they see real data, they see seriously real data, and then, of course, another form value, and of course it's still keylogged though. So they can do searches in the keylog function, but a lot of their searches will have trouble finding, and they'll usually go after softer targets. And there's plenty of softer targets out there that isn't the website. So medium, all basic values are valid. We're going to talk about prefixing and post-fixing data for post via client-side JavaScript, and post-parameter obfuscation with regex replacement. So let's take a look at this. So what we're going to do is we're going to load the form page. Now, the JavaScript mangling functions are sent in a GET request. So they don't know what you're doing to mangle your parameters as you send it out to post. So they, you can either change that by using sessioning, so each session ID can have a different mangling function, or you can change it by day. And usually when they look at these logs, it's like a good day, week, sometimes longer, later, when they go back to the site to try to figure out the data mangling function, it's totally different. So here's the typical prefix and postfix data mangling functions. Now, as we know, a credit card number is 16 characters. So they're going to do search strings, well, more advanced ones, for 16 character numbers. If you prefix and postfix numbers on it, it's not going to match their search strings. So they're going to go after other softer targets instead of them. So here we go, simple regex replacement, JavaScript, really simple, pound and the %. Next. And here we go with function change post. This is where we pull in the form into the DOM, create an element input, name it, make it hidden, rename it anything we want, run the mailing function, and here we take the CC number value and then replace it with anything else. So they can use fake numbers that don't match the checksum and basically make themselves very exposed to wrongdoing. Okay, here's the actual test of our thing that we're going to show later. As we can see, we mangled this, we added this text3 with the submit, and here's the change value, but it's still keylog. So you have to remember that it's still keylog. So it's a little harder for them to look. The keylogging still occurs, but it makes it harder. Okay, for hard, this is the real killer. First of all, form tags are not used in HTML pages at all. So just get rid of form tags. Because a lot of Zeuss works on the actual form submit. That's when it sends the keylog data and stuff. I know other Trojans just log all the posts, but that's like a big thing. We're going to use delayed Ajax posts. It often works off of like hitting the enter key or like a key strike, clicking a button. So by actually delaying the actual Ajax post by like maybe a few milliseconds, it often tricks the bot software a lot. Concatenation and tokenization, that's where we're going to take it all, put it in one big string, and then usually use either encoding or RC4 encryption, and then it's really hard for them to sort through everything. Next. Okay, here we go. Everybody know what base 64 encoding is? Everybody knows what encoding is? Okay. Quick hands. How many people have heard of base 91?
Base 91?
Base 91.
It's an encoding method.
It's an encoding method. Check it out. It's really good. I suggest it over base 64. There's a lot of base 64 functions. So, everybody knows what sessioning on servers is? Session IDs, all that fun stuff. Okay, next. Remember, we're from America. Okay, so let's go through the flow chart. We're going to create an HTML page with input parameters without form tags. Regular HTML button with an onClick JavaScript function. The onClick JavaScript function concatenates all the input tags into one long string with the delimiter. The concatenated value is then base64 encoded, or it's not really needed, or you can use many other encoding functions. I suggest switching the encoding functions daily. It's a lot of fun. And base64 string is then submitted with an Ajax post request. So here is a concatenation form variables JavaScript example. It's pretty straightforward. Just grabs all the input tags, puts it together in one thing, and then creates something and then sends it in a post function. So let's go over another technique. A sub technique is you can really bloat the logs at the same time. This is for like spy Trojans or just the general post loggers. So what we're going to do is we're going to load an HTML form page. And we're going to have an identifier number assigned by the server. It's going to be sent to the GET request. They're not going to touch it because they only see post. So then the client-side Ajax function is going to run a intermittent fake post request. Well, it's a real post request, but it's an intermittent useless data being sent to the server. So as the customer is looking at the site, this whole time it's going to go post, 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 with a whole bunch of bullshit that's just going to fill up their logs with crap. Okay. So then we have the onSubmit. Oh, back. Okay. The onSubmit, the real post data goes through, has the identifier number assigned by the server. Session variable has the parameter of the number, and then accepts the actual real post. So here's a Ajax post JavaScript example. This is pretty straightforward. You guys are smart, so we want to explain. Here's a real post function that we use. It's pretty straightforward. This is important. You need an Ajax return statement that loads your page again. Okay, we'll demonstrate this later with our examples. But that's kind of needed to actually refresh and reload the page if you want, or you can do, the div refreshing. So have an HTML page with no form tags, JavaScript submit button, Ajax post method that does not send the form submit. using session, convert post parameters in the server-side code, convert post parameters to session variables, process to your needs, and there are no logs. The Zeuss Trojan does not pick it up because it never gets a form submit. So, you know. Okay, RC4 encryption. For your really sensitive applications, I suggest RC4 encryption.
Yeah, the RC4 encryption, what we'll do is in the JavaScript, we'll send the actual RC4 key as a GET request. So when you load the page, download the JavaScript file. The JavaScript file is actually generated server-side dynamically. And what we'll do is we'll take everything we did before, you know, take the string, concatenate it together, encrypt it, base64 encode it, and then send it to the post. And we don't send the key with the data, and the server actually already knows what the key is
Through
the session variables. So they get a bunch of data, they don't know what the key is, depending on how your key generation works.
Now, I know the RC4 encryption is very weak, but the thing is that if you rotate the key, either per session ID or you rotate it per post, they will have very little of a target to try to decode this thing. And since that's kind of difficult, they're going to go after softer targets again.
Yeah, so I mean, it's not 100% foolproof because obviously the machine's already been compromised, and you know, they can just install some other software, but that's going to cost them time, hopefully money. You know, it's just a big.
Yeah. Remember, pocketbook. This is how simple an RC4 encryption thing in Java is. It's really simple to implement. Unfortunately, it kind of hits the server kind of hard, you know, because it's got to decrypt it every time. But RC4 is pretty quick, so that's why.
Could you translate to Spanish?
If you can read that, you're really pretty good.
Okay.
The other stuff is my understanding. So these examples do not prevent identity theft. If they really want your data, they're good.
Yeah, I mean, this isn't meant to target, you know, the Russian business network. Those guys, you know, that are selling their software for 10 grand, you know, it's not really going to be a big deal for them to modify the software and, you know, just recompile.
Well, we're going for the general consensus.
Yeah, I mean, we're looking at people that are getting this off of forums. We're looking at script kiddies that are downloading this off, you know, the public backdoor versions that they download. You know, those are the people that are, you know, just spray and pray. You know, they don't really. It's not a targeted attack. They're just compromising everybody they can and taking what they can. All right, so we'll do the questions now. Let's switch over to the demo.
Okay, everybody get your voting device. Get your right answer to anybody. Get your result. Okay, everybody test. Okay, everybody's works. So here we go. What is Zeus? Yes, it is a malware package. It's stolen. How does Zeus submit its stolen data? Yes.
Yeah, it is the HTTP post. Oh, here we go.
Okay, what's the percentage of machines infected? Malware?
Yeah, we tried to do some injection on the
Yeah.
questions here, but it didn't work.
Good VA process, secure coding, thanks Microsoft.
Yeah, 100%. These techniques will solve all of your problems. You can turn off the antivirus, turn off all of the firewalls and everything. We'll just take care of everything.
Quick solution. Okay, all right, now
Now we're going to switch over to the demo.
So did you guys talk to some banks about your ways, or do you have a library at the moment? How do you supply?
we're working on a type of library. Actually, the latest research we're doing is we're looking at an anti-web injects code, basically defeating, everybody knows about the web injects feature of Zeuss? Anybody that doesn't know? Okay. Zeuss has a great function where you can code, it has a text file that you tell it what to look for on a web page, or what web page, what to look for, and then it'll actually inject code client side, like it comes from the actual web page, and it'll inject. Typically, they want extra parameters like social security number, other stuff. Like your mother's maiden name, stuff like that, that's what it does. But there's actually Zeuss plugins that actually have like, well, I'll let you do the demo and then I'll talk about the plugins.
Alright, so here's the demo. Here is an example of a login form. You can see two parameters there. It's encrypted with 128-bit encryption, so obviously nobody's ever going to get your data. Unless you were certainly born. So, you get your username here, Marty, and my password is time machine. And I go ahead and log in. And it doesn't work. So give me 1 second here to make sure that my...
Okay, I'll talk about the plugin. I've seen, they have like mule software. And what it does is it actually has pre-made web injects to work with certain bank accounts, and it does by injecting, using the web injects function, it injects JavaScript that detects, when you're logged into the bank, and then it communicates back to the Mule software CNC server, which randomly generates a number that fits your amount that you have in your bank account, usually like 10, 15, whatever the currency is, and then it'll actually make an ACH transfer to a Mule account. It actually lists several Mule accounts. It's very awesome software. It's very evil, but it does that. And then from there, a malicious actor can then use those Mule accounts to do, Western Union money transfers, money packs.
Okay, so now it works. You can see, credentials worked. Here is what Zeuss sees again. Username, it's called username. Password is password. And then here that we hit. So this is what a normal login page with nothing that we've done looks like to Zeuss pretty much. Let's go to the basic method here. This is just a basic form that you go ahead and make a login form, but it's just, a form with the hidden inputs here. If we look at the source, you'll see the inputs right here, here. So what we do is type in your account number, submit it. Again, this is what it looks like to Zeuss. We already showed you the screenshots before. what this does is, once you type in your credit card number, so let's say, and then your account number is whatever. So what it's going to do is it's going to go through and actually replace the fields. If you watch it, you'll actually see it happen when I hit submit, and then this is what you'll get back. You see the credit card number. You know, obviously you don't want to put something obvious in there, but you want to put a fake credit card number. You know, some kind of flag number, so that, I mean, I know credit card companies actually do that. They'll have valid credit card numbers that actually work, but if you end up using them, then you're probably gonna get something on your door. So that's medium there. Here is a nice form to find out if your credit card's been stolen. So you just type in all your information and you hit check now, and then it'll actually tell you.
I suggest using it.
Yeah, I can give you the URL if you guys like.
If you want to
test it out later.
That's really helpful.
So you know, once you check it, apparently it's been stolen. So again, you can see this is actually the hard, but only the concatenation and tokenization. You can see the base 64 string up there. It's been cut off for some reason. I suck at CSS. But you can see the base 64 string, and then under here is the decoded data again. This next one here is hard. Now, you can't actually see it happening right now, but in the background, on a random delay, it's sending a post to the server. The way that works is, just does a set timeout.
After the talk, we can get together and we'll set up a web proxy and we'll show you all the transmissions that goes on.
And then that submit button isn't actually a submit type button. It's actually just HTML button with an on-click function. And what it does is when you type in all the data here and you hit submit request, it sets the callback to a window.location to where you're posting to. So as soon as the server receives the data, you get the callback and it'll move you to the next page. So it doesn't look any different to a user, but it actually works a lot different, and none of this data that's on the screen is going to be keylogged or logged in the logs for the server. Okay, that didn't work, but you get the idea. Alright, so
it refreshes to that page. It is view source to show.
No, it's perfect.
Well, we'll get it to work. So does anybody have any questions? Well,
we still have a few minutes, no?
any questions?
7 minutes.
Okay, we have 7 minutes for questions.
Yes.
So basically, all the solutions that you presented only work for very small players, and they're basically security by obscurity.
Well,
you only add like JavaScript functions.
Yes.
As soon as you will have a big player that adopts one of the solutions, you will have Zeus implement, or the Zeus guys will implement new functions and all that will get all the keys, and then you will.
But we're kind of.
they would have to actually look for, okay, yes, but they have to custom code a plugin per website. And that costs money, okay? Like, you can get the Mule software for a specific website. Like, and, for this bank, for this website, for this country, that costs money. They're going to buy regular Zeuss, and then they're going to have to actually buy that plugin, which costs more money and more time to set up and stuff like that. But yes, they will come up with coding stuff, but they're going to have to really, try. So, but the majority of the Zeuss users are low-end technology.
Well, for one side, you can, for part of your defenses, you can have general filters that will, or better filters that can work for that, and on the other side, it will cost a lot of money for the bank as well to implement these solutions.
Some of them, are easier, some of them are more difficult. But I mean, the whole point of it is that the users are compromised. Their antivirus is working or it's not doing anything or.
A lot of these you can use, well, risk factor comes in, and how much you want to put into programming risk. Like regular, like banking logins and stuff, they're not really going to do this because they want a mass package they've already made, but like ACH money transfer services and stuff where they actually have like just IP addresses where they transfer millions of dollars, they would probably take the time to use these techniques to try to make the actual login portals a lot safer and to look for stuff,
And again,
such as anti-web attacks.
the people we're trying to stop aren't, the guys that are coding this stuff, because they can just take anything, just recompile it, and they're done. We're targeting all of the other thousands of people that are just downloading the software and installing it.
But I mean, these techniques aren't too hard to do. So I mean, most really serious web developers could probably keep this up. But yeah, it will cost resources. It's something that they have to calculate into and stuff.
What websites are using these techniques right now?
Actually, a lot of websites are using something similar. They're actually using Flex applications. Because Flex never sends a form signal.
I think MasterCard uses it on their site.
Yeah, MasterCard, I think, uses it. And, American Express uses some of these things.
So, thank you for.
Any other questions at all?
Maybe sort of another element. Well, you could also emit like an extension to your work. You could emit some self-modifying code that, as you have the server application, the server application could generate some random JavaScript code that will then do some other stuff and just make it a lot harder to decrypt the.
Yeah, we've actually looked into using JavaScript obfuscation stuff. We wanted to make like a .NET plugin and stuff, but we got too busy with other stuff.
Yeah, I mean, this is kind of just
Like a basics, yeah.
Because if everybody implements exactly the same thing, then we're back where we started.
That's like captchas.
Yeah.
We'll be using the same captcha.
Yeah. But you had a question?
Yeah, it's not really a question for the statement. I mean, that's good fun, and it must be fun implementing that. But I think there is a side effect that it makes the whole website a whole lot more complicated.
Yes.
So as soon as you're going to stop to bug hunt something else, which is not to do with security, you have a really tough time working around all the obfuscation you can do in applying to the request.
Yeah, I think
This has to be taken into account when making decisions. Yeah, privacy or accounts are so important. We're going to do this.
Yes.
So this will be a negative side effect.
Yes. A lot of the usual methods that banks use now, which you can probably agree is the psychologist functions in it for monitoring. But this is for like super logins.
So, thank you for coming to my talk. We're really happy to be here in Switzerland.
Yes.
You guys